Let's now see how our functions can change values of our objects on specific locations. In this example, we created a new f variable with value 4. Then we created our new p1 variable as data type integer with pointer. Then we pass location of our f variable to our p1 variable, and then we print our p1 variable. We want to create function which in this case will change value of specific variable on specific location. So that function will look like this. Our new function change value has one input variable. That input variable have alias q and the data type is integer with pointer. In this case, we are passing specific location to our input variable. In our implementation, we wrote *q and then we assigned new value to that location. When we wrote *q, we access values of that specific object on specific location, and we assigned new value to that object. Let's execute change value function inside of our main function. On line 11, we execute our change value function, and for input variable, we passed our p1 variable. After that, when we print p1 variable, we see that our function changed value of our p1 variable, but location of that variable is still the same. If we want to clear location from our p1 variable, we can assign nil value to our p1. For our case with p1 variable, we passed variable with pointer. What if we have variable without pointer? Let's say we want to initialize new variable with specific value. We have new variable t1 with value 7. We want to know how we can pass this variable to our change value function. Because this variable isn't connected with specific pointer, we cannot pass pointer to our function. Instead of that, we will pass specific location of this t1 variable. In front of our variable, we will write ampersand sign, which means that we are passing location of this object. Now, when we print our t1 variable, output will look like this. Let's now see how we can pass our structures with pointers to our functions. For this example, we want to create two new functions. First function will look like this. Function calculate sale will have two input variables, where first will be float 32 and second will be keyboard structure with pointer. Also, this function must return us value with data type float 32. Second function will be function set price with two input variables. First variable will have data type float 32 and second will have keyboard struct with pointer. We want to assign new value to our price attribute inside of our keyboard structure. Inside of our main function, we will create two new variables, where first we'll have data type keyboard and second we'll have data type keyboard with pointer. Let's calculate our sale from our function for these two objects. So now we want to know what is the difference between these two calls. In first call, we are passing specific location because our first object isn't connected with pointer. On the other hand, in second call, we are passing pointer, not specific location, because second object is data type keyboard, which is connected with pointer. Because of that, in first example, in front of our kb1 variable, we are writing ampersand sign. In second case, we will just pass kb2 variable to our function because that is already pointer. When we print our new values, output will look like this. The same pattern will apply for our set price function. In first call, we will pass location of our kb1 variable. In second call of our set price function, we will just pass kb2 variable because in this case we are already passing pointer. Let's now explain two different approach of our new function. We created constructor for our structure. This constructor will be new item function and it will give us object of data type item with pointer. Let's see how we can create our item object with pointer in two different ways. Inside of our main function, we created E1 new variable. For this case, we initialize new value with our built-in function new. To this function, we can pass only specific data type which we want to use. Our new function with lowercase n only return us pointers to initialized memory. This means that when we print our E1 variable, we will see new object with 0 states for values of our attributes. If we try to create E2 variable with new function, and inside of that function we try to initialize values for our attributes, we will get an error because this writing is not allowed. For that case, if we want new object with pointers, but also we need to initialize new values for our attributes, we will use constructor. We created E2 variable and we initialized new value with our new item function, which is constructor for our item structure. We passed three values which we want to assign to attributes inside of our item structure. Now, when we print our E2 variable, we can see object with pointer, but also with new values inside of that object. This is very important to us because in that way we can connect many different functions which are related to one specific structure. We want to see how we can connect many functions as one result. In this example, we will create new structure, extra costs. This structure will have two attributes, where first attribute will be all costs for our machines, and second attribute will be all costs for our employees. We will create a new extra costs function, which will be our constructor for our extra costs structure. Now we want to create another function which will be connected to our extra cost structure. We created new function, calculate all extra costs, and we have one input variable for this function. Inside of our implementation, we will sum all costs for our machines and all costs for our employees. This will be our ms and es variables. Then we will sum these two variables as float 32 and then we will multiply them by index variable. Index variable is alias for our input variable. We must realize one thing. If we want to connect any two functions, we must create specific traffic between them. Output of our first function must be input of our second function. Let's see how that thing works inside of our practical example. We want to connect our new extra costs function with our function calculate all extra costs. Function new extra costs return extra cost structure with pointer. Function calculate all extra costs have input extra costs structure with pointer, which means that these two functions can be connected. Let's now see how we can execute these two functions. Inside of our main function, we created L1 and L2 variables as data type slice of integers 64. We created a new variable E1 from our new extra costs function. This E1 variable can call our calculate all extra costs function because type of E1 is extra costs. Function calculate all extra costs is connected to our extra costs structure. So we will call this function like this. Our C1 variable will initialize call from our calculate all extra cost function, and we will get value as data type float 32. We can see that output and our result from our printing on line 36. But now, because we can connect new extra costs and calculate all extra cost function, we can write our calculation like this. We created new variable E2. We called our constructor from our new extra costs function, but now, because we can connect these two functions, that function didn't return us specific result, and instead of that, immediately call another function, which in this case will be calculate all extra costs function. Instead of first call, we will get value from our second call, and instead of returning structure with pointer, this statement will return us value of data type float 32. We can see that type and value of our C1 and E2 variables is the same. So now we understood how we can connect many functions and return one specific result. Let's now write example where we will create function which is connected with specific structure, but that function will modify another object on another specific location. In this example, we will create two new structures, department and salary. We want to create function which is connected to our department structure, but that function will update specific value of new object which will have data type of salary with pointer. That means that we will assign new values to our salary object on a specific location. In this function, first we will access our department structure, then we will access ID attribute. From that attribute, we will take only first character. If that character is number 3, then we will update average value inside of our salary object by following formula. Let's now see how we can execute this inside of our main function. First, we will create two new objects, D and S. At this point, value of our attribute average inside of our salary object is 0. What is the point in calling of our functions here? Our salary struct can't call average salary function. Only department structure can do that. We will access our D variable, then our D variable will call our average salary, and now we will pass to that function our S variable. When we print value and location of our S variable, we can see the difference. Location is still the same, but now value of our average attribute inside of our salary object is updated with new value. So now we understood how we can create function which is connected to one specific structure, but we will modify totally another data type with another specific structure with pointer. In the next video, we will see how we can create variadic functions and how we can create functions which doesn't have final number of input variables.